So, hi everyone. Well, children are going to be increasingly exposed to robots. We saw it in Joe's talk, right? And we're going to have learning companions or play things that do things, to cite one of my heroes, the late Edith Ackerman. And no matter the application and the form of the robot, roboticists will face the challenge to design for a user group that is in development. And children are developing their understanding of agency and causation, and they play along with the illusion of life in a more pronounced way than adults. And this can make our job increasingly challenging, and because it impacts the child-robot interaction greatly. And in this problem space, I focus on those low-cost, low-anthropomorphic robots that they rely less on anthropomorphic cues to communicate, and they have less degrees of freedom, like the famous one that you can see there. And those robots are entering children's everyday life, and they are already impacting children's development. And as it is happening now, it is timely important to understand how to design behaviors for those robots, able to minimize the challenge that the children brings about in the interaction, and in a way to have the perception of affordances that make sense and reason with the way children understand agents. And I'm very much interested on this topic in interactions that are shared. So shared interaction along object or shared interaction between a child and a robot. And here there is an example of them. So the child is looking at a cake and he has a certain intention. And I want to understand what is the minimal communicative act with a degree of freedom available with the low anthropomorphic robot that you can see, that can create common ground enough to make the intentions of a robot transparent and to meaningfully communicate in the interaction. And no, I'm not working on cookie monsters or cake monster robots, but I'm working in object-oriented tasks. So in scenarios where the robot is there, is maybe reactive but socially engaged, and is playing with you and maybe is cooperative, giving you hints. And we built our technology probe, to cite again Joe. It's a semi-hemispherical robot with only limited degrees of freedom that can pan itself to signal attention to the user or to the objects in the interaction. And in this scenario, we explore two minimal behaviors that are based solely on this motion. And what are they? We call it social gaze movement, that are communicating the social engagement of the robot in the task, that say, hey, I'm here, I see you, I'm following the flow of the task. They are modeled on attentional nonverbal behaviors that are monitoring the recipient in front of the robot. They are designed as simple shifts of the base synchronous to the recipient movement with minimal latency and following the recipient orientation. And we design Deictic-gaze movement that are signaling referential information in the scenario, redirecting the attention of the recipient to a piece of information, like here when it's redirecting to the last missing chalk to complete the task. They are simple shifts oriented to the object of interest, and they look like a bit like pointing. But here the question is, okay, these minimal nonverbal behaviors are simple, but how they communicate? Are they legible? What kind of effect do they have on the perception of animacy that, especially with children, maps onto constructs of agency and causality? And what kind of impression the children will form about the robot? Would it be positive impression? Would the robot be likable? And would the robot be able also to communicate complex intentions, like, for example, the fact that the robot is cooperative, is helpful? And to understand that, we evaluate this prototype in a 2x2 between a subject design study, where we expose the children to videos of the robots interacting in this manner. And we had 72 children look at these videos, and we asked them about legibility, animacy, likability, and helpfulness. And a group of children saw social gaze movements coupled with Deictic-gaze movement, others just social gaze movements, others Deictic-gaze movements, and a group, unfortunately, see nothing at all because the robot was static. what we found is quite remarkable, even though it might sound obvious to you, is that the children were actually able to reason about what the action of the robot were meaning in the interaction, were able to recognize what the robot was doing, and the behaviors, both social gaze and deictic-gaze, were legible. And even though both social gaze movements and deictic-gaze movement impact the perception of animacy, its social gaze movements were really powerful and impacted the perception of animacy and likability way more than the deictic-gaze movement. So probably a behavior that signal, hey, I'm here, I'm aware of you, I'm following you, signal also the fact that the robot is lifelike, is an object that has some kind of agency, and it has some goals maybe in their interaction, and is doing this with me. And the deictic-gaze movements, of course, impacted the helpfulness by virtue of the fact that they were actually delivering the helpful information. And, but what we found is that even though they were communicating this, is where when social gaze movements and the deictic-gaze movement were combined together, that we reached not only the greatest animacy, but also the rating of helpfulness was going up. So what does it mean? That these minimal nonverbal behaviors might go along together. They might be combined to really have the maximum of communication. And what I would like you to take home today is that minimal movements can go a long way, that children can understand minimal nonverbal behaviors in this way because they reason with their way to make sense of agent, and that social gaze movements are powerful. We can use them to make connection with the child and to really make the sense that the robot is there doing something with the child. And then, in general, carefully designed minimal nonverbal behavior can be used to communicate also complex robot intention. So we don't need behaviors maybe with complex generation like we see in robotics. And first of all, I want to thank you that you listened to me. I'm Cristina Zaga. If you want to know more, you can go and read my paper. And if you want to know more also what happened in person in situ study, or what happened with adults, or what are our ideas on how these may unfold in sustained interaction, please catch on with me and we can grab coffee together. Thank you very much.
So we have time for 1 or 2 questions before we move to the next one. If you can come close to the microphone. No, wait, we'll wait, it's okay.
Tom Erickson, IBM. Interesting